Hello, everyone, and welcome to the August 2025 edition of the St. Louis Java Users Group. Next slide. For those who don't know, the St. Louis Java Users Group is an informal group. Our first meeting was May of 1997, so we've been around here for a while. Attendance is free. There is no formal membership list. We try to meet on the second Thursday of every month except December, when there is no meeting. There's just too many things going on over the holidays for us to be able to organize a meeting in December. Once in a while, we will deviate from that to accommodate a speaker's schedule. And you can join us for food and social if you're here in person at 6 p.m. and we aim to start the meeting at 6:30. This live stream is originating from the Object Computing Incorporated Training Room. That's at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. Next slide. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Zach Klein, Ted Doyle, Robert Levitt, Wei Chi Gao, and Bruce Allspoil, that's me. And you can reach all of us on the steering committee if you send an email to that address at the bottom of your screen. That's javasigsc@googlegroups.com. Next slide. The St. Louis Java Users Group would not be possible without the support of our sponsors. So Object Computing Incorporated is our original lead sponsor. They've been with us since 1997 and they've bailed us out so many times I can't even begin to count. They are supplying the training room tonight and the drinks tonight as well, and all the AV and lots of things to make that possible. At the end of the meeting, we will be raffling 2 Manning ebooks and get this, 4 JetBrains licenses this time for any product of your choice. But the rub is you must be present to win. So I'm sorry, if you're watching the YouTube recording, you're too late. You could be present online or in person. Now we do need additional sponsors, particularly for food and things like that. So if you know a sponsor or are interested in sponsoring the group, please email us at the steering committee email address. Once again, that's javasigsc@googlegroups.com. Next slide. Manning has given us a 40% off discount code for any of their products. So when you walk through their store, you can apply that code, JUG13. Next slide. We have some great presentations lined up. In fact, we're scheduled out now through the end of the year since we don't meet in December. So next month, it's going to be Better Understanding Through Bytecode by Jason Clark, who works at GitHub. What is this about? It's like you're programming an assembly language, but it's the bytecode for the Java virtual machine. If you want to actually write JVM bytecode, and what is it that's really going on under the hood when you run that bytecode inside of the JVM, this is the meeting to find out what that JVM is really doing. On October 9th, WebAssembly is getting to be a pretty hot topic too. And that is another, you can almost think of it as bytecode, but it runs inside your web browser. And that's going to be by Harry Kempel of New Relic. Yes, he's coming all the way from Germany. No, not virtually, in person for this one. November 13th. Oh my God, do I even want to admit it? Which birthday of mine that is? It's Simpler Java Build Tools with Object-Oriented Programming by Howell Lee. He's coming all the way from Singapore. Holy moly, to talk about that. What he's done, if you look, he has come up, a lot of people have heard of Maven and Gradle. He has his own build system that he's working on, and it's called Mill Build. And you can Google search that, and you can find out about his build system that he's coming in. And he's the designer of this, and he's been working on this, I think, for like 5 years to come up with that. So those are our upcoming schedules. Next slide. So if you want to keep up with our presentation schedule, that's easy to do. Just go to our Meetup website. That's meetup.com /gateway-jug. And as we schedule presentations, they get posted on Meetup, and you can RSVP for any or all of these meetings here right now that they're up on Meetup. This meeting is being recorded, and probably sometime over the weekend, I will attempt to upload the recording to my YouTube channel, which we started over the pandemic. And I thought, oh yeah, that pandemic will be over out of recording a Zoom meeting after about 3 or 4 months. Well, we've been doing it ever since like 2020 and it just kind of grew. But anyway, it's youtube.com/@ and my name, @Bruce Allspaw. Now, if you're interested in giving a presentation or sponsoring a group, once again, if you want to give one of these, just email us on the steering committee again. That's javasigsc@googlegroups.com. Next slide. So I'm going to turn things over here to Tom Wheeler, who I understand is a former OCI employee, and he's back to tell us about durable execution here with Temporal. So why don't you take it away here, Tom?
All right, thank you. Want to make sure, is the mic coming through? Okay, fantastic. All right. There's some sort of graphics issue that prevented me from playing the slideshow normally, so I'm just going to sort of thumb through it this way. It takes up most of the screen. Hopefully it's pretty visible. Indeed, I work for Temporal. I'm a principal developer advocate there. Previously, I worked for about 10 years at Cloudera, developing training material. Before that, I was at OCI for 8 years. And before that, I was a software engineer at WebMD. And then I was a software engineer at A.G. Edwards & Sons. And that's how I first came to know OCI. I worked with Mark Volkman, Paul Jensen, a handful of others. I'm really impressed by the caliber of those developers. And a few years later, when I was deciding that I was going to leave WebMD, I decided that I would go to OCI, where all the smart people were. And I learned a lot and enjoyed it, and sort of taken a different path since then. And now I work for Temporal. And I'm going to tell you what Temporal is. What is Temporal? You may wonder. Well, Temporal is both a company, the company I work for, and a software. And so people may wonder, well, okay, what is the software? That's what I'm going to focus on. I'm going to focus much more on the software than the company. This is not a sales pitch. I'm here to tell you like what it is our software does and why it's useful to you and why it's different than other things that you've seen before and why it will make your lives as developers easier. That's the focus of my talk. But what is Temporal? Temporal is an open source, durable execution platform. And when you hear this, it may raise the question, okay, what is a durable execution platform? What's durable execution? And so I'm going to answer that, but I'm going to take a sort of roundabout way to get here because I want to focus on like the problems that it solves, the problems that I as a developer experience, the problem that you as developers have probably also experienced, and how Temporal tries to address those, because it exists to solve problems. If you think about some trends that have taken place over the last 15, 20, 25 years in computing, back in the day, we used to write software and it'd run on one little machine, you know, with a single processor, and you didn't have to worry about concurrency, and everything was easy, and the memory was local, and you'd call local functions, and that was great. Everything was easy. You had very limited scalability, but you didn't have a lot of problems. And then the internet happened, and you know, infrastructure started moving to the cloud, and the companies that had big data centers, like for example, when I worked at A.G. Edwards, we had a huge data center there. We had a mainframe in our building. We had tons of Sun servers and HP Unix servers and all sorts of other servers. We had another backup data center in Creve Coeur on Lindbergh for disaster recovery. And we had, you know, all kinds of machines and WAN connections and all this kind of stuff. And that was common for them. When I was at Boeing as an OCI employee, they had a huge data center on premises there. And so it was enormous. It was multiple times the size of this room, and it was just rack after rack after rack of machines. And that was common. Well, infrastructure started moving to the cloud, and people don't deal with like physical servers sitting in a rack with a switch and Ethernet cables connecting one to another. People use, virtual infrastructure that exists by the cloud providers. And that's great because we don't have these operational expenses of having to buy hundreds of machines, and we don't have to buy more machines than we really need because it takes 6 months to fill out the forms and do the requisition and, get the servers ordered and get them delivered and install the software and get them put in the rack. And, all that takes a long time. When I was doing as a software developer, I had to sort of anticipate how much capacity I'm going to need 6 months from now. And then we would run at like 25% utilization, give ourselves some headroom. So if the application experienced growth, we weren't constrained. We should sort of ramp up until we could get new machines to expand our capacity. Now it's easy for anyone to deploy an application globally, to have points of presence around the world and not have to buy physical machines to do it, not have to go to a data center and plug machines into a rack or load software on them. You can automate all of this, and it's infrastructure that's made possible through the cloud providers. So it's great. Another trend that's happened though, is we've moved from sort of local functions running on a single machine, to, people have adopted microservices and services-based architecture. And so instead of having local functions, you're calling some component, and it doesn't really matter what language that other component is developed in. You could be a Java developer and you can make a REST API call to a service. It doesn't matter what that's implemented in. It doesn't matter what the database is in the back end. There's a lot of benefits of this approach. You can scale each of these services independently. You can give them the resources they need, based on the demand that you're seeing. You don't have to deploy them all as a single unit. So you could upgrade, for example, in e-commerce sort of scenario, you can make changes to the inventory service without breaking the payment service. You can evolve these things individually as your needs change. And that's great. Gives us, when you combine that with a cloud infrastructure, together those things give us a lot of flexibility. It gives us a lot of opportunities for scalability. And this has led to the situation where modern applications are effectively distributed systems. There's more potential for scalability, but there's also a lot more opportunities for failure, because what used to be local function calls are now remote procedure calls, and they're taking place across different networks, often across the internet, sometimes multiple services. And if you have a failure or outage or a network glitch with one of them on either side of the connection, it can cause cascading failures and things can go very wrong. And trying to solve these sort of problems is difficult. Distributed computing was a very niche area of computing for a long time, but everybody has to face it now. Everybody has to deal with it, but not a lot of people sort of recognize that they're distributed systems developers. I'd say every modern developer is a distributed systems developer. And so I'm going to go through an example, sort of the theme of this. The code that I'm going to show is based on money transfer. And Temporal is used for a lot of things, and money movement is one of them. There's a lot of financial companies that use Temporal to make their applications reliable, to enable them to withstand crashes and service outages and all sorts of other problems. And I'll talk more about that later. I want to be clear though, in the beginning, Temporal is used for a lot of things. Netflix, for example, uses it to deploy cloud infrastructure. And Twilio uses it to process messages. Coinbase uses it for processing financial transactions. Alaska Airlines uses it for reservations, to manage the reservation system and to make sure that you don't sell 2 seats on a plane to, or 1 seat on a plane to 2 different people. So there's a lot of different use cases for Temporal. It's not just something that has to do with finance or just money movement. That is a common use case, but I'm using this as an example because it's easy to follow and it's easy to understand, and I think it makes a good example. So this is a distributed system. Imagine that I need to pay. Imagine that I make a bet with somebody in this room. We bet about, whatever, and I lose and I have to pay you money, or you buy concert tickets and I have to pay you back or whatever. Well, people use things like Venmo and, Zelle and all sorts of ways to transfer money from one person to another. And as users, it's such a convenient interface. It looks like you're only doing one thing. I'm giving you money. But what's actually happened is it's taking money out of your account and it's putting it in, or out of my account, it's putting it into your account. So those are actually two different operations. It's sort of one big operation, but there's two more specific operations that take place to make that happen. So two steps there. And so this is some simple code showing kind of the happy path. And as developers, this is the greatest thing in the world. Somebody says, okay, you need to call an API for one bank and withdraw some money, and call an API for another bank and deposit the money there, and you're all done. Seems simple. Okay, so it's 4 lines of code. Great. And then you get into the real world and you start discovering why programming is harder than it first seems. So the first problem you might encounter is that the service is unavailable. You're trying to call this API provided by a bank, but you can't make a connection because that service is down. Maybe it's down for maintenance. Maybe they had some sort of hardware failure. Maybe the network connection is down on their side, could be down on your side, could be down somewhere in the middle, could be bad router, bad cable, whatever. But regardless of the specific case, the problem is you can't make the connection you need. So and this is something I've done in lots of different languages, and you probably have too, the first thing you think of, okay, well, I'm gonna move that call. Instead of just making a call and it fails and then I'm out of luck, I'm gonna move that call inside a loop. And if it fails, I'm just gonna retry. So you implement retries, and now your code gets a little bit more messy. And by the way, the code samples that I'm showing here, I'm not expecting you to read every line of code. It's very small. It's hard to fit it all on the screen. I'm showing you sort of a descent into madness. So you solve that problem. Now you have another problem. You call the service, but it returns an error. So for example, you do the withdrawal, let's say that succeeds, and then you go to do the deposit and it says service unavailable or 500 internal server error or whatever. Could be that the account is closed, so you can't put the money in. So then you need to do some sort of compensating transaction to get to reconcile the account balances. You need to take the money that you withdrew. Since you can't deposit it, you've got to put it back where it came from. Otherwise, the account balances are going to be off. So in distributed systems, this is called the saga pattern, where you have some sort of recovery step or a set of recovery steps to sort of undo the state changes that you'd made before. So here in this case, we're going to redeposit the money back into the source account and everything's going to be fine. And so now your code gets a little more complex. We went from 4 lines to maybe, I don't know, 50 lines of code there. You have another problem. Eventually you're going to encounter, well, you are able to make a socket connection to the service. I mean, you're connected to it. So you've got connectivity. The network is up and running and the service is up and running, but maybe it's overloaded. So you're able to connect and issue the request, but you don't actually get a response back. You can't wait around forever. I mean, eventually you've got to complete this transaction or undo it. So you need success or failure within a specified time period. So you start to implement support for timeouts. And if something takes longer than you should, you say, for example, we expect this to complete within 10 seconds. Otherwise, we'll assume that it's timed out and then sort of roll back the transaction. So you implement that, and now you've got thread pools and all sorts of other stuff to deal with, and your code gets more complex. So at the end of all this, you think, well, there's a lot of work to get here. Nobody sets out to write code that looks like what you have on the right. Everybody sets out to write code that looks like what you have on the left. But when you go from development to production, this is what happens. Like your code winds up like that. And don't feel bad because it's happened to me and I've implemented this kind of stuff in 5 different languages at least. So you think, well, it was a long way to get here, but is this code going to work reliably now? I mean, I've implemented supports for retries, for timeouts, for compensating transactions. Like, what else could there be? Well, there's a big problem here. The correctness of this money transfer requires that we apply both operations exactly once. We've got to withdraw the money and then we've got to deposit the money. We can't do one of them twice. We can't do one of them 0 times. We need basically exactly once execution, or effectively once execution at any rate. So what happens if we do the withdrawal and before we do the deposit, the code crashes, the application crashes? And it could happen for a variety of reasons. You could have, for example, a bug in the code, like a divide by 0 error. You could have a null pointer exception that was unhandled. You could have a bug in the JVM. You could have a power outage. You could have hardware failure. You could have any kernel panic in the operating system. Any number of things could cause this code to terminate prematurely without making it all the way to the end. And if that happens, now the account balances are out of whack. And the remedy there is not, well, let's run this thing again, because you're not getting the exactly once execution you need. What would happen in this case, unless you've written code to handle this, is you would do another withdrawal, and then you do the deposit. Let's say it succeeds. Well, great. Now $100 or whatever amount of money you were transferring is still lost from the original source account. So you can't recover by just restarting. What you need to do is resume the transaction from where it left off. And so as developers, you can write a ton of code to do this. It is possible. I've done it. You may have done it as well, but boy, is it complicated. And it's one of those things that's really tricky to get right at scale. Like, things can work correctly when you're running at a small scale, and when you sort of scale up, you discover race conditions and problems that, only expose themselves when you're really operating at high scale. So now I'm going to show you some code. And for the first demo, let's see, can you see this? Is that visible in the back? Okay. Okay, so I've got some code here. And this has nothing, the code I'm going to show you has nothing to do with Temporal. This is just code. The simplest sort of code that I could write in Java. Maybe not the simplest, but pretty simple. I have a class, and it has a main method. And that main method calls a function or a method called count2, and it passes an integer. So it's going to count to 10. And down here we have the definition of that method, and it just has a for loop, and it counts from 1 to whatever the number passed in was. And at each point along the way, it prints out that number, and then it sleeps for 1 second. That's it. Okay? Simple code. I will point out one thing, though. For a long time, I learned Java in 1998, and it was around for a few years before I learned it. And for most of that time, the thread.sleep call takes a value in milliseconds. I think in like 2010 sort of time frame, somewhere in there, they added, like, you could specify it in nanoseconds, but there was no way to specify, oh, let's sleep for 3 days. There's no way to specify, let's sleep for a month, right? And as Java developers, you're thinking, well, that's crazy. Why would I couldn't sleep for 3 days? My code's not going to be running in 3 days because of all the problems I talked about before. Because there's going to be a bug in the JVM, there's going to be a kernel panic, the system administrators are going to apply a patch, and your machine gets rebooted, the container's going to blow up, the hardware's going to fail, the power's going to go out. All of those things that can interrupt your application is the exact reason that the designers of the language didn't have a convenient way of saying, let's sleep for a really long time. Just as a side note, with Temporal, you can sleep for a month. And if you want to do something like, instead of a cron job, where you say, let's run this every month, you can just have a for loop, and you can run some code, and you can say, sleep for 30 days. And it's completely reliable, because if the thing crashes, it recovers automatically. If the hardware fails, it can resume execution on another machine. And I'm going to show you some of these things, but I just did want to point out this about the Java language. And most other languages, the built-in sleep statement expects that you're going to specify a duration that is like a fraction of a second, maybe a few seconds. Okay, so now you've seen the code, and I'm going to run it. And I just have a little shell script to compile this, and it's counting 1, 2, 3, 4, and I'm going to kill it. And so now I'm going to run it again. I sort of let the cat out of the bag, but what number is it going to print when I run this? It stopped at 5. That's where I killed it. 1, right. And you all know this because you are developers, right? But if you go ask your neighbor, think of someone in your life who is not a developer, someone who is non-technical, and you say, okay, we're going to run this thing that counts to 1 to 10, and you explain the code to them, and they get what it does, and you run it, and then you kill it halfway through, and then you start it back up. You say, what numbers are going to print? They're probably going to say 6, because they don't know how computers work. What they're telling you is how they think computers ought to work. And what I'm here to show you today is that they can work that way. And the fact that they can will change how you approach programming. Okay, so that is normal execution. So winding my way back to why I'm here. So here's durable execution. Same thing. I wrote some code. I won't show you the code in a moment, but I kill it just like before. Boom, it's dead. Now when I run it again, apparently, there we go. So it picked up from where it left off. It's a simple thing, like, okay, big deal. It picks up from where it left off, but it changes everything, because You may not realize it, but your entire approach, and this is true of me as well, your entire approach to software development, if you're working on production systems, is based around failure. It's centered around failure. You don't think about the happy path. You do it first. You know, you spend a few minutes on it, and then the rest of your life, every time you get paged, every time you get an email about a system going down, it's all about failure. It's negative engineering. And if you can overcome failure, and when something happens to crash, you can pick it right up where it left off again. That makes your job a lot easier. Not only is your software more reliable, but your job as a developer is a lot easier because you're not spending your life thinking about everything that could go wrong, trying to anticipate every problem. You're spending your time thinking about what is the goal? What is the outcome that I should achieve from my code? And that's ultimately what code is. It's a set of instructions for how to achieve some goal. So make it as simple as possible. And you can do that if you have durable execution. So durable execution is crash-proof execution. That's the definition. You can't prevent crashes. Crashes are inevitable. You know, I listed a bunch of reasons why they could occur: power outages, kernel panics, hardware failures, whatever. You can't prevent those things. They're going to happen, but you can make them inconsequential. You can keep them from disrupting your application. Yes, question. Oh, okay, go ahead. I don't think so. Not yet. Yeah. I'm going to go back to my high school and give the same presentation. Yeah. So durable execution is crash-proof execution. That's the thing to walk away from, or walk away with. And it's, as I said before, it's revolutionary. It's a simple concept, but the impact of this, the fact that your program can continue running as if that failure never even happened, that crash never even happened, will change how you approach things. It's obvious that if you can overcome failure, your applications are going to be more reliable. And when people begin using Temporal, and there are thousands and thousands of companies that are running in production at big scale applications you use all the time, it makes them reliable. And that's why these companies come to Temporal and begin using it, and they're like, okay, we need reliability. And so they come for that. But then what they realize is, because you're not centered around this negative engineering, you're not sort of focused on all the potential problems, you can focus on the goal, and your code becomes a lot simpler. And that means that you can write applications that take less time to develop, and they're less work to maintain, and they're easier to debug because you have the happy path is right there, and you don't have to worry about all the different problems. You're sort of pushing complexity out of your application into the platform because it's able to handle crashes, retries, timeouts, all sorts of problems. That's what I'm getting at here. So back to the definition. What is Temporal? It's an open source durable execution platform. It automatically maintains the state within your application. So when you set a variable, the value of all your variables, as your program is running, as we were going through that for loop, I was incrementing the value of the variable I. At first it was 1, then it was 2, then it was 3, and so on. When the program exits, two things happen. Number one, the value of all those variables that I would set in my code, they're all gone. The application state is disappeared. The other problem is the program counter gets reset. I don't mean the literal counter in my program, but the thing within the computer that knows what is already run and what is left to do. So you don't have any notion of like what happened and what's left to run. So that makes recovery very difficult because, as I said, just restarting something is not the right approach. You want to resume. So Temporal enables applications to recover from crashes as if they never even happened, and you just saw that. It also has built-in support for retries and timeouts so that you can survive things that are less severe. For example, you're trying to call a service that goes down or the network goes down. There's a lot of libraries that can do those. For every language you use, there's multiple libraries that can handle that. And that's cool, and Temporal does it really, really well, and it's proven at scale, like running at this like unheard of scale. The ability to recover from crashes as if they never even happened, that is more novel, because in order to do that, you need something external to your application. If your application crashed, it's no longer running, how can it recover itself? So you need something sort of external to that to monitor and help it recover. And I'll talk more about how that works. You'll see it in action, but point I want to make is that those are two separate things. Like failures and timeouts, that's one class of problems that you may encounter. Crashes are an entirely different and much more difficult thing to take care of. And then finally, as I mentioned, it improves developer productivity because it makes the applications easier to develop, easier to scale, and easier to support. You can understand the code because it's not cluttered up with lots of error handling. Temporal is open source. There's two parts of Temporal. I'll talk more about the architecture in just a moment. There's two parts of it. There's a library that you put within your application called an SDK, Temporal SDK. It's like any other library. It's you would install it with Maven or Gradle. If you're using Java, you can write Temporal applications in a number of different languages. So if you're using Python, you would use pip or something like that to install it. It's just a library that you put in your application that provides some APIs and some support that your application will use. Then there is a temporal service, this thing that is running external to your application that your application communicates with about the state changes. I'll talk more about it in a little bit, but this is the license of the the server component is, let me back up. All of Temporal software, the libraries, the SDKs, and the Temporal service is all open source. The Temporal server software is MIT licensed. The Java SDK is ASL 2.0. All the other ones, so the libraries we support, Go, PHP, Python, Ruby, .NET, a handful of other TypeScript, handful of other languages. Those are all released under the MIT license as well. But for historical reasons, because the Java SDK was developed from some code that our founders wrote when they were software engineers at Amazon, like 15 or more years ago, that code was originally licensed under ASL. So the Java one is, for this reason, historical reason, it's a derivative work of something earlier. So it's under ASL. But anyway, my point is it's all open source. It allows commercial use. It allows modification, distribution, private use. Pretty much the only thing you can not do is say that you wrote it. You can't say, this is my code. You have to leave the copyright notices in there. Okay, so now I'm going to go into some core concepts, and then I'll do some demos. The first concept, the first part of Temporal's architecture is called a workflow. A workflow is the core abstraction within Temporal. It's the main part of your application. It orchestrates your business logic. So in the example that I showed before, money transfer is a workflow. We're trying to do, move money from over here to over there. That word workflow has a lot of baggage. Depending on where you came from as a developer, maybe you had to suffer through like business processing, modeling, notation kind of stuff and draw pictures of what you want to do, or you had to write your business logic in YAML or some sort of weird configuration file when all you wanted to do was write code. Well, I've got good news for you. Temporal has a workflows as code approach. So when you hear workflow, all it is a function or a method, depending on which language you use to implement it, that has durable execution. So in Java, it's a method. And once that method begins running, it's able to survive a crash. It's able to survive a hardware failure, any of that stuff. So when you hear workflow, just think durable execution. Don't think about drawing little pictures of what you want your code to do. It's just Java code. And you can use your favorite IDE. You can use your favorite libraries. You can use your favorite, you can do unit testing of it. You can keep the code in Git or whatever source control system you want. You can use whatever build tool you want. It's just Java code. In Java SDK, it's a method. You have an annotation to say workflow method and workflow interface. I'll show you the code in a moment, but that's basically it. It doesn't impose naming conventions on you or anything like that. There is one catch though. I mean, durable execution is great, but there is a price that you pay for it. Your code has to be deterministic. So you can't do anything that is going to behave differently from one invocation to the next. So anytime, I'll give you some examples of things that are deterministic. Well, basic arithmetic. If you add 2 plus 2, the answer is 4. It doesn't matter how many times you do that or what time of day you do that, the answer is always going to be 4. On the other hand, if you try to calculate like how many minutes is it now since noon, how long is it till lunchtime, that depends on what time you're running it. If you're trying to write to a file system, that is non-deterministic because it could be that the disk is full or that the permissions don't allow you to write to the file. If you're trying to make a network call. It could be that the service is down or the network down. You could get different results based on conditions external to the application. So you can't do any of that stuff. And you're probably now thinking, wait, that's all the stuff I need to do in my application. I need to call some network service and I need to write the results to a file and I need to query a database. That's okay, because there's an escape hatch. And it's called an activity. And an activity is just it's a method, just like a workflow method. And it allows you to write, or it allows you to do non-deterministic things. So you can call network services, you can write to files, you can do date calculations or whatever, and it's totally fine to do it inside there. There is one difference. It's also a method and it's annotated, much like a workflow method is. But the core difference between a workflow and an activity, a workflow has to be deterministic, an activity doesn't have to be. But a workflow has durable execution and an activity does not. And this is where retries come into play. So activities are where you do unreliable things like call a network service, query a database or whatever. Those things could fail. If they fail, they just get retried automatically. And you can configure the behavior of those retries. There's a default setting for how it happens, but you can configure those and it gets retried and it'll continue to be retried until the thing succeeds or until you cancel it. So anytime you want to do something unreliable, you put that in an activity. Anything you want to be reliable, you put that in the workflow. That's it. So to give you an example of what I'm talking about, in what I showed before, the money transfer is the workflow, and the individual operations that are used to carry out the actual movement of money, those are activities. So withdraw and deposit, those are activities. And the workflow calls or request execution of the activities. So workflows can take input and they can return values. Same thing with activities. Now, how does the workflow and activity code get run? How does it get executed? The answer is this thing called a worker. The worker is what is responsible for running the workflow and activity code. And the worker is provided by the Temporal SDK. You don't have to write one. It's just an API that you use, and in your code, you start one. You configure it. You say, this worker can run this workflow and these activities. And you can set some performance tuning sort of parameters, some information about security certificates and stuff like that, but that's pretty much it. It's common to run multiple workers. You can just run one, and that's what I was doing in the example I showed before, but it's common to run multiple of them, and that's what you do in production, because each additional worker that you run increases the application's overall availability and throughput. So if you're running 100 workers and one of them dies, then the other ones take over for it automatically. If you're only running one worker and it dies, then there is no progress until you sort of bring that thing back up. And you can bring it up on another machine, whatever. But if you have a bunch of workers deployed to a bunch of different machines, you can survive the loss of some number of workers and some number of machines, and the application will just keep going. So to recap, this is the code that you develop. You write the workflow code, the activity code, and you configure and start the workers. The Temporal SDK provides an implementation of the worker, and the client that manages communication with a temporal service. I hinted about the temporal service earlier. It's a backend system that is managing the workflow execution. It's the thing that is keeping track of state changes in your application. I want to make something clear though, the temporal service does not execute your code. The worker executes your code. The temporal service is separate from that. Probably, in most cases, it's running on a separate machine. In my case, I'm running everything on the same laptop, but in a production system, just like you would run your database and your web server on two different machines, you're going to run the temporal service in your application on two different machines. If you didn't, and the machine died, you would be out of luck. So you want to have some isolation between those. So the temporal service creates tasks, it manages task queues, and the workers hold the task queue and say, hey, got anything for me to do? And the task will contain information about which function to run, which arguments to pass to it, and so on. So the worker picks up the task, executes the workflow or activity using the input provided, and then it returns a result back to the temporal service and said, okay, I queried the database and the answer was 9, whatever it is that the particular activity is doing. So that's it. All the while, when the worker picks the thing up and when the task gets scheduled, when it gets completed and so forth, the temporal service is maintaining an event history that is tracking every step along the way. So it knows every activity that ran, every input parameter that was passed to it, what the result was, how long it took to run, all of that information. And that's good for debugging but it's also what allows the thing to recover from failure. Nathan. It is separate. Yeah, the temporal service is implemented in Go, but you can deploy it. I'll repeat the question for the people online. Do I have to do anything to make sure that the worker can communicate with the temporal service? And this is a great segue into the next slide. Applications are external to the temporal service. I'm reiterating here that the application is running somewhere external, usually on a different machine than the temporal service. The temporal service does not run your code. It just tells the worker what to do. The worker is the thing that runs your code. And the connectivity requirement is simple. The temporal application, the worker, has to be able to contact the temporal service. It uses one TCP port. By default, it's 7233. It uses gRPC for communication. You can encrypt it with TLS. That is typical in a production environment. And the communication flow is such that the worker always contacts the temporal service. So the worker makes the request, the temporal service responds. The temporal service does not know about the workers. It gets a request and it gives back a response, and that's it. So you don't have to worry about, like, some protocols, FTP, for example, you've got multiple ports and connections get initiated in reverse. There's none of that complexity. It's just a simple single TCP port. That's it. Okay, so enough with the theory. I'm going to introduce a couple more things, and we're going to dive into the actual examples. So here's the temporal command line interface. It's just called Temporal, and it lets you, from the command line, interact with a temporal service. You can list the workflow executions that are running right now. You can start them, you can cancel them, all sorts of things like that. But it also has the ability to run a temporal service. So if you're on a Mac, you can just type in, and you have Homebrew install, you can say brew install temporal, hit enter, and then that will install the temporal CLI. If you use Linux or Windows or some other operating system, the source is available on GitHub. And we also have precompiled binaries available for multiple architectures. And so you can download that, just put it in your path. I think when you download it, it's a zip file or a tar.g zip file. You just decompress it, put it in your path, and you're off to the races. There's no external dependencies or anything like that. And to start the local temporal service, you say temporal server start dev, and that starts it with the default settings. It takes about maybe 1 second to start up. I'll show an example. Excuse me, I started before the demo, but I'll show an example of it. There's also, Temporal also has a web UI. This is one of the coolest features of all. It's a really powerful tool for observability because it lets you see what is running right now, what has run in the past, and you can dive right in and, like, explore. If there's a failure, you can see a stack trace of where the code is failing. You can see every detail, like which machine it ran on, what the process ID was, all sorts of stuff. I'll show you what it looks like in just a moment. The way you access it sort of depends on how it's deployed, but if you are using the temporal CLI and that temporal server start dev command that I showed before, it'll run on port 8233. So you just fire up your browser, go to port 8233. That's it. But you can specify a different port if you want. Here's what it looks like. The main page shows a list of all the workflow executions. The ones that are running currently are up at the top, and you can see there's a status column there. The ones that have completed or failed or canceled or whatever are shown below. You have some other information like what kind of workflow it is, the timestamp, and so on. You can filter this list based on the status, the ID, timestamp, and other stuff. But if you click one of these rows for a particular workflow execution, it shows you the detail page. That shows you the status, like this one completed successfully. It shows you some other details like when was this thing started, when did it end, how long was the total duration, the total execution time, what was the name of the task queue that this was running on, how many state transitions there were, and then a little further down, you can see the input that was passed to the workflow execution. You can see the result, the value that it returned. Then there's a timeline showing each of the operations that it performed. Here, it did a withdrawal followed by a deposit. And you can see exactly how long those took relative to one another, how much delay there was between them. And below that, there's a table listing this entire event history that I mentioned before. So you have all the detail you want. And this is great because, at least for me as a developer, I would have applications that I had to support. People would call me or email me and say, hey, the the program crashed. I'm like, okay, what was the input? I don't know. It was yesterday. What was the error message? I don't know. I closed the window. I'm like, okay, well, now I don't know how to debug it. Here, you can go back and look at what happened. So you can easily find, every execution. And what is especially nice, I don't know if you can see this here, but this says JSON, where I'm moving my mouse, sort of to the left of where the 6 is. You can actually download this JSON file, which is a complete workflow execution in JSON format, and you can replay that in a debugger, and you can recreate like a 1 in a million problem. So there's an API called workflow or worker.replay, and you pass it this file, and it'll go through exactly the same steps that it went through the first time with this, everything. Everything's exactly as it was. So whenever the application crashes or blows up or whatever, you can find it. It's all right there. Okay. Yes.
On.
Question
I have
from
a
Mona.
question online. When designing a temporal workflow of multiple activities, for example, book hotel, book airline ticket, book rental car, book local excursions, what are the best practices for assigning workers? Should a single worker process for all activities or have separate worker for each activity? Thanks. And that comes out of Wayne, I mean.
Okay. I mean, the simplest thing to do when you're getting started is just to have, so a worker can run any number of activities. You have to register, and I'll show you this when I show the code for the worker, but you have to tell the worker which workflows and activities it's allowed to run. But a given worker could run, 5 different workflows. It could run like process order or manage payment or transfer money or, anything. And then all the different activities, you have to register those as well. So there's really no rules, hard and fast rules, but in terms of best performance, there are good reasons that you might want to isolate them into different things, but honestly, that's something that I wouldn't worry about until you get to a certain scale. And at that point, the details matter. Yeah. Okay, so just to wrap it up, and I'm gonna then get into the demos, workflows are stateful and resilient thanks to durable execution. They orchestrate the business logic, but the catch is they have to behave deterministically. Luckily, you can use activities to encapsulate any non-deterministic operations. If you need to do anything that interacts with the outside world, for example, to call a service or query a database, you put that stuff in an activity. Activities don't have durable execution. And if they fail, though, they just get retried automatically until they succeed. And then the program continues running as if that problem never even happened. The temporal service doesn't run your code. It manages the tasks and history of each workflow execution. And the workers are what run the code, and they just pull the temporal service to say, what should I do? And they take direction from that. The worker and the temporal service typically deploy to separate machines. And, conclusion. I had these 2 slides out of order. Okay, so code, demo, and walkthrough. So let me show you the money transfer. Okay. The thing that I'm running here is a little Java Swing application that I wrote. This has nothing to do with temporal, mostly. There's one tiny thing I'll show later that has something to do with temporal. But this is just like modeling the bank accounts. It's easier to understand like what's happening with failure scenarios if you can actually see in real time bank balances and stuff. So this is just a GUI. It's backed by a MongoDB database. And so I've got $1,000 in my account, and I'm going to add an account for Jim. I met Jim on the way in, so Jim now has $1,000. So let's say that I need to send Jim $100 and switch over to here and go into the money transfer. Now I'm going to run this first, and then I'm going to show you the code, and then I'm going to run it a few more times in different failure scenarios. So I've got a shell script here, which is all this shell script is doing. It's just calling Maven clean compile and exec Java and passing in these arguments, because there's no way I could remember this and type it in correctly every time. So transfer money from Tom to Jim, $100. I may have messed something up when I sort of half ran the thing just now. bear with me for just 1 second. Oh, okay. Yeah, what I forgot to do, and this is it used to be in the early days of Temporal when I first started there, 3.5 years ago. This is something you could waste hours on. And luckily our awesome designers, they put a message in to tell you like, hey, here's the problem. So the problem was, remember when I said workers run your code? Well, I didn't have a worker running. So I need to run a worker. Okay. There, the balance went down to $900. Well, here's the Temporal Web UI. You can see here's the money transfer, here's the input data. It produced confirmation numbers of the withdrawal and the deposit. It did the deposit, the withdrawal. The reason we have this long sort of gap here is because I didn't have any workers running. Let me try that again. That'll be a little less exciting when that. Okay. Okay, I'm gonna send Jim another $100, and you'll see my balance goes down to 800. His will go up to 1,200. Again, this is the happy path. Everything works fine. But now I'm going to show you what the code looks like. And some of the code I'm going to sort of skip over. I'll come back to it because there's like, I want to explain the basics and then come back and explain some additional things. So I will show you here's the workflow. And like many things in Java, you have an interface and an implementation. And so here's the interface, and this is the workflow, money transfer workflow. And we have an annotation to say this is a workflow interface, designating it as a workflow. Within there, we have two methods. This thing called transfer, which is the workflow method. That's the thing that's orchestrating the movement of money from one place to another. And then there's this other thing called a signal method, which we're going to skip over for now. I'll cover that a little later. It's unrelated to like what I've showed you. Now let's look at the activity. Again, we have a interface and we use annotations to say, here's some activities. In this case, we have two different activities. One activity method is called withdraw. It takes a account number, an amount, and a reference ID, which is a unique number for the transaction for the bank. And then we have another one called deposit, very similar input. And they both return a string, which is just, you can return whatever you want. In this case, it's the confirmation number for the operation. But that's what it looks like. That's the interface. Now, we'll dive into the implementation. So up at the top, this is where I have retry handling, and there's a default, so I didn't have to set anything but this timeout here. But I set a start to close timeout. There's a bunch of different types of timeouts in Temporal, but start to close means how long do we expect this thing to run? And I'm saying 10 seconds. If the transfer were to take more than 10 seconds, then this would time out. And so we can set it to whatever number you want, but typically you'll set it to just a bit longer than the maximum you expect something to take. The other thing that happens here is setting the retry options. I don't have to do any of these because it'll use the default settings. The default settings are when an activity fails, it'll retry after 1 second after failure, then it'll double, then it'll double again, and it'll keep doing that until it reaches the maximum of 100 seconds. And it'll keep going forever until you cancel it or until it succeeds. In this case, I've specified things just to be explicit for demonstration purposes. So the initial interval, how long after the first failure do we retry? It's set to 1 second. Well, that's the default value. I didn't have to put that in there, but I just want to show you what it looks like. Back off coefficient is how much do we increase it each subsequent time? This is a multiplier. And then the maximum interval, like at what point do we plateau? And for purposes of demonstration, I have overridden that from 100 seconds, which is the default, to 20 seconds. So we don't have to wait as long between retries for reasons that you'll see in a little bit. You can also designate certain classes of failures or exceptions as things that you should not retry. And I've done this here. If there's insufficient funds, like I try to do the withdrawal, but it fails because there's not enough money in the account, I don't want to keep retrying that forever. So this one says, if we encounter that, just stop. And then either the workflow can handle that in some different way, And if it's not handled, then the workflow execution will fail. And so that's up to you how you want to do your business logic. You could also retry that. And then when somebody eventually puts money in the account, then the retry will succeed and everything will continue on from there. So scrolling down to where we get into the implementation for transfer, I've overridden the transfer method because that's the workflow method here. I take as input the details, the source account, the target account, the amount, and the ID. I have some logger. Ignore this part. We'll get back to this in a moment. And same thing with this. We'll talk about that section a little bit. But here's where I do the withdrawal. I'm using the activities to call the withdrawal method, and I pass in the sender's account, the amount, and the withdrawal unique ID. And then down here, I do the deposit into the other account, and that's it. So that's the total implementation.
We have another question.
Yeah.
Does do not try accept multiple exceptions?
Yeah, you can specify any number of exception classes you want there. And then I'll also point out there's in the retry policy, you can designate specific classes that you don't want to retry, but you can also do that on kind of a one-off basis, not based on type, but based on a specific instance. So you could have a try-catch block, for example, and then you could say, okay, we're going to try to do this, and if it fails, then we're going to do something else and don't retry if that fails. So you have a lot of capabilities there. Okay, now I'm going to show you a service outage. So let's say I'm going to send Jim another $100 because I make a bunch of bad bets here. And I'm going to transfer money to Jim, another $100. But as you can see, his bank is down. I click the button, so that service is down. So you'll see my balance goes down to 700, and it just did. But the thing is still running. I don't see any activity there. So let's say Jim calls me up and says, hey, where's the money? I say, it's a great question. The check is in the mail. And then I refresh the Temporal web UI and I go in and see that this thing is running. And then I can see this sort of line, the red line here that's showing, I don't know if it's visible on the screen, but it's like sort of moving. There's motion with it. And this is telling me that there's a failure. And if I look over on the left, it says attempt 6. And in a little bit, it's going to say attempt 7. This is the retries in action. So it's failed 6 times. Now it just tried again. It's failing. It's going to continue retrying until that service comes back up. And so, bless you. I'm going to bring the service back up now, and I'm not going to touch anything else. I'm going to sort of scroll up just a little bit. See that it says running over here in the upper left corner, and see this red line? All right. Now I'm taking my hands off the machine. There's no hocus pocus here, but you're going to see with no activity on my part, no interaction at all, once the service comes back up, in the next retry attempt, the thing succeeds. And so the transfer is now complete, even despite that outage. And we can see there's the result. And if we go down here, I mean, we can see like if Jim has a question next week, hey, why did it take so long for the money to get to me? I can say, well, it took 8 attempts. Let's see why that was. And if I scroll down, I can see the error message. Oh, it's a legal state exception. Bank Jim is currently unavailable. Well, your bank was down. That's the reason. And I can see the stack trace of the entire thing. It tells me exactly which line of code was failing. And so you have unprecedented ability to see like back into the past as to what took place. Okay, so let me show you something else. Now, I do the same thing, stop his account, or stop the service rather. I'm going to run this again. So before I do, go back here. My balance has gone down, his has not gone up. Same story as before. When I refresh this, we'll see one's running. But now, and actually let me just scroll down just a little bit. We can see, you know, the pending activity is deposit, like this is failing. All right. Now let's look at durable execution. The thing, who recalls what is the name of the thing that is running your code? The worker, that's right. So here's the worker, and I can see And the terminal where I started that, it's telling me like, hey, this thing's failing, legal state exception, the bank is unavailable. All right, so application crash, boom, the worker's dead. It's no longer running. And if I refresh this, it won't give me that yellow error message again, because even though there's no worker running, it is based on 5 minutes. Since there's one been running within the last 5 minutes, it doesn't show me that error message. Now I'm going to start it up again, but believe me, there are 0 workers running right now. And what I'm going to show you though, is that my balance will remain at $600. In here, we've already done the withdrawal, so it's not going to do that again. It's just going to do the deposit. And so we'll see that his balance goes up. Mine does not change though. So run it again. I'm just going to scroll up where we can see the status there. Oh, we got to, of course, start that. And it takes a few seconds for things to get up and running again and to recover from the failure that we had. Boom, it's all done. And so my balance still 600, his went up to 1400. So it was able to recover from that crash. And so what's happened, this may cause you to wonder, like, what's really happening under the hood? How is it able to recover? And the idea behind it is pretty simple. Normally, when you run something, the operating system starts up a new process, it allocates memory and CPU and stuff like that, and then your code is running happily within that. And if everything goes fine, your application exits and the process then exits. But if things go bad, it's the other way around. The process exits, your code then terminates, and that's not good. And that's the end of the story with a normal execution. With durable execution, what happens is it essentially virtualizes the execution so that it can continue on in another process. And the worker uses the information from the event history, this sort of representation of everything that took place. It uses this information to reconstruct the state of the execution, and then it continues execution in another process. And if there is a hardware failure, it can continue that on another machine. It just picks up right where it left off. And that's it. That's the gist of it. Any questions about what I've shown so far? Yeah.
Either the application or the worker streaming those events to the server through gRPC, is that a synchronous or blocking flow? Does that, in other words, does that wait for an acknowledgement before it continues on execution? I'm just curious, I guess where I'm going with this is there any performance penalty for the application to buy into this process?
I didn't hear the last part. The very last part.
Any performance penalty, I'll just summarize it with that.
Yeah, so this is something that people ask about a lot. Is there like a performance penalty in terms of latency? Usually is how it's expressed. And the answer is, yeah, there is latency involved in doing this, because if you did not have, if you did not have, durable execution, if you weren't tracking state changes in the way that it is, then, every communication that takes place between the worker and the temporal service, there's a request and then a response, and there's network overhead with that. It's usually in the milliseconds, the tens of milliseconds or something like that. But, for a bunch of state changes, they'll collectively add up. So there is latency, but the latency is typically, most people find that the latency is low enough that the benefits of the durable execution, the reliability, is much better than the detriment of some latency. And so, for example, it's widely used in financial transaction processing, money movement, stuff like that, where people are doing stuff at high volume and they need high performance. And so they're doing it, at that scale. There's tons of companies that are doing it. And before Temporal, it wasn't that they weren't doing that at all. It's that they had come up with their own system for being able to do it. And their own systems, generally speaking, were slower than what Temporal is. Because Temporal is just, to give some history about Temporal, by the way, our co-founders, the company was started in 2019, and it was forked from an open source code base of a system called Cadence. Cadence was written by our co-founders at Uber. They were software engineers at Uber. And so they built this system to do orchestration there within Uber, and it took off like wildfire. They built it for their own team, and a bunch of teams nearby are like, wait, how did you do this? You've solved problems that we have. and sort of took off like wildfire within Uber. And then because the Uber had open sourced it, there were a lot of other companies that were using Cadence, and they're like, hey, we'd like better security. We'd like support for additional programming languages and stuff like that. We'd like more, better performance. We'd like this and that. But because they were software engineers at Uber, they were being paid to do what Uber wanted them to do. So they couldn't really address the needs of a bunch of companies that were not Uber. So for that reason, they left Uber, forked the code base, and then created Temporal and started adding all these improvements that a bunch of other companies wanted. But interestingly, you could say that Temporal is like a fourth generation version of this, because one of the co-founders had been at Microsoft, and he created something that ultimately led to the Azure Durable Functions. It was the Azure Durable Task Framework is what he created, but ultimately that became Azure Durable Functions. And then a few years before that, both co-founders worked together at Amazon, and they created a system there called Simple Workflow Service. And that was like the first kind of iteration of this stuff. And it was like, I don't know, 15 years ago. So it's not very often in your life that you get to have a good idea and implement it, and then like think, man, I wish I could have done that better, and get another chance at another, enormous tech company to do it again, and then say, yeah, this is better, but there's still some things we could do. And then you get to do it again at Uber, a different tech company, and then you get to do it again for your own company. And at this point, you have like 15 years of experience of how to do it right. Anyway, my point is, there's definitely latency involved with tracking the state changes and stuff, but broadly speaking, most companies find that the benefits far outweigh it. I would not use Temporal for like high frequency trading. I wouldn't use it to control control systems on nuclear reactors. There's a handful of cases where avionics, handful of cases where I think the latency might be a significant issue, but for most other business type of use case, I would say typically not. Yes. Oh, I'm sorry.
So I'm assuming you wouldn't run the temporal service on a remote machine. You would be on the machine with the application.
Yeah. So the
And
question,
that you would, if you had multiple applications, could they share the same temporal that was on the same machine with them, or they each need to have their own?
yeah. So there's two questions there. The first is, would you run the temporal service on the same machine as the application? And the answer is probably not. Like certainly in production, you would probably have those in separate machines, probably in separate racks if they're in the same data center, in separate racks, so that if like one machine died, you don't lose everything. If one rack catches fire, you've got some isolation. You probably have them deployed to different machines and different racks. In fact, you might even run them in different data centers. And so the temporal service also is not like a single horizontal or vertically scalable thing. It's horizontally scalable. So you can deploy the temporal service across a bunch of different machines. And incidentally, Temporal, you may be wondering, and I'll just answer the question now, how does Temporal make money? How is it, Tom, that you get paid? This open source software, you said it's all open source, the service and all the libraries and so forth, and it is all open source, 100% under very liberal licenses that allow you to use them. We have a managed service, a temporal service, but like as a cloud service, that you can use as an alternative to hosting it yourself. That's the way that we make money. You can host it yourself, absolutely. So I would say it's a similar situation to like Apache web server. You can absolutely host the Apache web server yourself. I did it for many, many years on my DSL connection at home. At some point I said, yeah, I want my website to be up, and I don't want to have to patch it every day, and I don't want to have to worry about monitoring it, maintaining it, and all that kind of stuff. And I much rather let somebody else take care of that. So that's kind of the same situation with Temporal. Yeah, you can run, but there's two answers. The question is, does it work well with Kubernetes? I'm going to go back. The answer is yes, but I want to give a little bit of color here. If I go back to my diagram of what all this looks like, there's two parts of the overall system. There's the temporal service, and then there's the application. And I just want to be clear here, you can deploy both of these to Kubernetes. Temporal Cloud, the service that we have, should you choose to use it, it replaces this. I mean, it doesn't replace it, but you're not responsible for running it. We're running it, and you don't have to bother with it. So it gets rid of this part of it, but you still run your application. So your application can run in Kubernetes. The temporal service can run in Kubernetes. You could deploy both of those to bare metal. You could run both of those in virtual machines. You could run it any way you want. You have a lot of flexibility in the deployment. We generally say like the application, you can build it however you want. You can deploy it however you want. Whatever way you build and deploy your applications is the way that you would do it with Temporal. We don't impose a bunch of restrictions on it. The Temporal service can run inside of Docker. I'm running it here on my laptop, but you can run it. I'm running it from the Temporal CLI. By the way, I said that I'd show you what that looked like before. Here it is. I just typed Temporal server start dev, and there it's running. So that's it. Yes.
Is there any integration, all this instrumentation you have in that UI there, is there any way to integrate that with other, tracing and monitoring tools, OpenTelemetry? Can you consume that data, put it into a Grafana dashboard? Like, how accessible is all that metadata that you're racking up through the Temporal service?
Yeah, there's you can use it with a bunch of different tools. It's very common for people to use Grafana. There's Prometheus endpoints for the metrics that it generates. Also, you can use what are called interceptors. It's an API that we provide that allows you to sort of get information about every call as it happens. And that's sometimes people will do that if they want to know details about invocations that are not visible in metrics necessarily. So you have a lot of flexibility there. Yes.
Question from online. Should Temporal and its database always run in a clustered setup?
Great question. Yeah. Should Temporal and its database always run in a clustered setup? I'd say the answer is yes. Like in production, you would want to have redundancy across machines. You'd want that for your database. You'd want it for the Temporal service. You can deploy the Temporal service to multiple machines running, in a sort of clustered way. In fact, we call that a temporal cluster. And you can deploy it in Kubernetes. You can deploy it on bare metal hardware, whatever. But if you have multiple machines, then you're not you don't have a single point of failure. Oh, and by the way, let me actually demonstrate this. This brings up a question. Sometimes people will wonder, and I'll just show you the answer. What happens if the Temporal service goes down? People wonder that. Before I show you the answer, I'm going to restart the Temporal service, but I'm going to use a different option. So if you run this locally, as you would for development, by default, it just uses an in-memory database, which is obviously not what you'd want to use in production. So I'm going to say db file name, oral db, and using this db file name just tells it serialize the data to a SQLite database at this path instead of storing it in memory. That'll allow it to withstand crashes. So all the workflow executions that you saw before, when I refresh this, they're going to be gone because they were just being held in memory. So now we're sort of back to zero. All right, so I'm going to transfer another $100 to Jim. I'm running out of money. I'm in a very expensive proposition. Okay. Oh, darn it. I should have. Oh, wait, why is it stopped? Oh, insufficient funds. Did I say $100? I don't know. Yeah, I don't know. Let me try that again. Actually, we're gonna go the other way. You're gonna send me some money. All right. But I'm going to stop mine. So now the money's going the other way. So his went down to 1,400. Mine is failing because the bank is unavailable. Now, let's say in the middle of this, the Temporal service itself crashes. Nice knowing you. And so when we refresh this, up, gone, but we bring it back up. And there it is. It did the withdrawal, it's still trying to do the deposit. So I'm only running a single instance of the Temporal service in this case. I'm running on my laptop. It's not a single point of failure, but it's a single point of availability, because if it goes down, nothing happens until it comes back up. You don't want to have that situation in production, which is why you would deploy it to multiple machines. But as you can see, the data was not lost. And now if I start my bank service again, take my hands off the machine, boom, it completed. So to recap, the application can crash, the temporal service can crash. It's able to overcome all of those things. But you probably want to run this on, you know, actual real production hardware. If you're using it in production, you would do the same things you do in production for any other application. Yes.
And then somebody else or the other worker actually picks up that work and starts doing something with it. How would that be handled? I guess like in this case, like, would it both of them like actually do the deposit, or would it like come back alive and say, oh, this work is already done, so I don't need to do it again? Like, how would that be handled?
Yeah. So the question is like, what if one worker sort of one worker does not get the task done, and then another one picks it up, and then the worker comes back on, comes back up again. This is managed by the temporal task queue. So the temporal service is written such that only one worker will have the task at any point. And so if the worker were to, the task times out, it doesn't get the thing done within time, and the temporal service believes that the worker has crashed, then it's going to reschedule the task and another worker can pick it up. And if the first worker sort of comes back online, its result would be ignored, and the one that it had been assigned to will get it done. But this brings up an important point. How do you prevent like two deposits from happening? And the answer is you need your code to be idempotent. You need to write your code in such a way that if that does happen, and it's a corner case, it doesn't, it's 1 in a million chance, but it still does happen. You need to write your code in such a way that it protects itself against that. And that's not something the temporal service can do because it requires some knowledge of your application. Typically, like in terms of payments, if you're using Stripe or something, they have this built into their API. You provide an idempotency key, the unique ID that you specify that goes along with the transaction, and they're keeping track of all the requests. And if you make a request with the same ID as one you previously made, they just ignore it and say, you already did this. And so if you're building services for yourself, you generally take the same approach. And there are some unique IDs within Temporal. The workflow ID is guaranteed to be unique among all workflow executions that are running within what's called the namespace, but sort of you're part of the temporal service. So if you, for example, and you'll typically choose some sort of business ID, business meaning ID for your workflow ID. So in an e-commerce sort of use case, you might have the invoice number. That might be your workflow ID. And that way, if somebody clicks submit twice on the button, they're ordering something, they're like, check out, okay, submit. And they click it twice, and then sort of two requests come in, but they're effectively the same request. They have the same invoice number. And if you have if you're using the invoice number as the unique workflow identifier, then it's not going to run that twice. You can configure whether it just redirects to the one that's already running or whether it throws an error. It's up to you, but it's guaranteed that you'll only have one workflow execution with a given ID running at any moment in time. Any other questions? All right, let me show one other thing here. Show you the part of the code that I did not show before. I skipped over some stuff. Let's say, let me check my balances here. Jim, he's got a bunch of money. Okay, we're gonna send $1,000. Jim's gonna send me $1,000 because he's got $1,400 on his account. And so one thing that people often want to be able to do is have human in the loop steps. Like you want to automate a bunch of stuff, but there's like some approval process that's manual. You're seeing a lot of this with agents, for example, where you have agentic AI, which is a very, very popular use case for Temporal. Lots and lots of companies are doing that. And so often you don't want to just say, okay, agent, go do a bunch of things without any supervision at all. Like if the agent is going to spend money or, do something that you might not want it to do without at least checking with you first, you can have a human in the loop step where in order to proceed, you have to explicitly enable that. So I'm going to show that here. And so let's say for this bank transfer, anytime that the amount of the transfer exceeds $500, we have to have manager approval. If it's less than $500, it's not worth the manager's time. If it's over $500, they just have to look it over and make sure it's not fraud. I've actually already implemented that, and I'll show you what it looks like. So I hit enter. And you'll see that Jim's balance does not go down. And mine also did not go up. So it sort of, it didn't return, it didn't show an error message, but it sort of just stuck there. And so if I go in here and look at this, you're like, hey, what's going on? There's like no progress. Well, you can click the call stack and it will tell you, if you scroll down in here, says, okay, this thing is stuck on a call called workflow.await, and that is being called from the transfer method of the workflow implementation, line 49. Okay, well, let's have a look at line 49. Hey, sure enough, workflow await, just like it said, it's right there. Oh, here's what's happening. So up above, I check if the amount is over $500, then we set this Boolean as manager approval to false. And then down here, we say you need to await until has manager approval resolves to true. So effectively, these two things together says we are paused right here. This is blocking until has manager approval gets set to true, at which point it'll continue running. This begs the question, okay, great, well, this thing's running. How do you set that to true? And the answer, there's a feature that is built into Temporal called a signal. A signal is how you can pass data into a workflow execution that's already running. Obviously, when you start a workflow execution, you can pass data as input. You saw that before because that's how I specified the amount of the transfer, the account numbers, and so on. But how about if you want to send a message to something that's already running? And the answer is a signal. So we'll scroll down. I'll show you how that's implemented. Down here, or actually, let me go back to the workflow interface right there. I designate this method called approve as a signal method. And it takes a input parameter, manager name. And so here's the implementation of that. And it just says this has now been approved. And now it sets that has manager approval Boolean to true. And so you're able to flip that bit right there, which means that the workflow.await is going to resolve because this is now true. So I just need to send the signal. There's a bunch of ways that you can send the signal. One of them is the web UI. I'll just do it through the web UI. Where's my browser? Here we go. Okay. Here I can terminate workflow executions. I can start workflow executions that are just like this one, but with different input. But I'm going to send a signal and approve. It automatically knows the name is approved. And the data that I specify has to be in JSON format, which is why I'm going to use some weird coding here. And we're going to say that Steve Womack, beloved audience member, is the approver. I click submit, boom. And as soon as I do that, the thing completed. And I can see, like, there the deposit is, and scrolling down, workflow execution signaled. And so there's the data. I can know who it was that approved it and the thing completed. So you can pass data into a workflow execution using a signal. There's also kind of the opposite of this, which is you can inspect the state of a workflow execution and return the value using something called a query. So I could write a query, for example, if somebody wanted to say who approved this and find it out programmatically, so you could show it in the UI. And so you would just, in the code, you just go down here and say, well, you do it here. In fact, let's just throw caution to the wind. Who approved? That takes no input. Now I go over here. The only problem is I don't have a variable for manager name, so I'm going to define a member variable up at the top now to keep track of this. And there we go. See if it works. Because I changed the code, I had to recompile and redeploy. So now I'm going to do it again. This time, send the money back to Jim. It's blocked. Okay, we'll send the signal. Now, I can do a query. Well, it doesn't let me do one from the web UI. That's okay. I could do this through an API. All the SDKs support it. And by the way, you can send a query or a signal in a different language than what the workflow is written in, and activities can be implemented in different language than the workflow. So you could have a workflow that's written in Java that's calling activities written in Python. You can send signals from a different SDK and so on. So temporal workflow query name. What did I call that? Who approved? So I can find out, I could do it, through an API, I could do it through the command line, but a query is the opposite of the signal. Signal allows you to send data into a running workflow and you can change its state. A query allows you to inspect the state of a workflow and you can have it return a value, whatever you want. So I think that's pretty much it for my demo. So let me wrap up the presentation itself. Temporal is an open source durable execution platform. It traces its heritage back to systems that the co-founders created when they were software engineers at Uber circa 2015. One of them, actually both of them were at Microsoft, but one of them created the thing with Microsoft Azure. That was 2012 maybe. And then they both worked together at Amazon in 2010, maybe a little bit earlier than that. So this is their fourth time creating systems, but they're proven at scale, running very large scale. They're fantastic software engineers. The engineers we have are super high caliber people, some of the smartest people I've ever worked with. Temporal offers SDKs for a bunch of different programming languages. Java's one, but also Go, TypeScript, Python, PHP, Ruby, and .NET. Workflows are the core abstraction. They have the benefit of durable execution. So once the workflow method begins running, it's not going to crash. I mean, it can crash, but it'll recover from it. It's crash proof. And what I mean by crash proof, like I have a watch here, and this is a waterproof watch. Because I have a waterproof watch, it doesn't prevent me from falling into the Mississippi River. I can still fall into the river, but if I do, the watch is going to continue running. So that's what I mean by crash proof. You can't prevent crashes, but you can survive them, and they don't have to disrupt your application. That's what Temporal is all about. Your workflow code has to be deterministic, but if you need to do non-deterministic things, you just put that code into an activity. They get automatically retried upon failure. The workers are the things that execute your application code, as you saw. After you make a change to the workflow or activity code, you have to restart the workers. So those changes take effect because things are cached. The temporal service does not run your code. It orchestrates the execution of your code. And it does that through dynamically created task queues that the workers pull. It has capacity to be able to do some work. It picks up those tasks and begins running it. As you saw, the web UI helps you gain insight into your application. And you can find out more. That we've got tutorials, sample code, free training, all at learn.temporal.io. Okay, now for a trivia question. Does anybody know? Oh, there's a question, another question? Okay.
Yeah, there is. Could you quickly go over how to do rollback in the workflow.
Yeah, so I didn't show an example of that in the temporal code, but typically you'll do it with a saga pattern. And so you can try something, and then if that fails, you can have in the catch block, you can have it do something that undoes the state changes that happened from a previous thing. And so in the if you go to Temporal's samples Java repository, there are tons of samples that show how to do all kinds of different things with Temporal. And one of them is called Booking Saga. And so it shows you that sort of implementation. Like we're going to try to reserve a car and a hotel and a flight. And if one of those things fail, then we do something here that sort of rolls back or undoes those previous operations. So that's what the code looks like to do that. Okay. Other questions? Okay, I have a question for you. Does anyone, oh, you.
I have an idea. Webster console at where I used to work, and I used to see that as the cursor that it looks very similar to the cursor
Huh.
that keeps on spinning around and around. So it's a little like a sphere with some of it hidden.
Yeah, well, it is. Does anybody know the sort of creature that is Temporal's mascot or know its name? You know? Okay, what is it? All right, do you know its name? Ziggy, that's right, Ziggy the tardigrade. Tardigrades are small but mighty creatures. They're like under 0.5 millimeter in length. They can survive extreme variations in temperature. They can survive hundreds of times the radiation dose of humans. Yes.
Isn't there already Ziggy the Ziguana, who's the mascot of the Zig programming language?
I'm aware of the Zig programming language, but I don't know their mascot. So it could be. Well, I think tardigrades and iguanas can coexist. They can survive intense radiation. They can survive for decades without food or water. The perfect mascot for Temporal because it makes applications invincible. National Geographic says you can boil them, bake them, deep freeze them, crush them, dehydrate them, or even blast them into space. And when we saw that, we said, that's a great idea. So we sent Ziggy into space with a Raspberry Pi running a Temporal workflow written in Python, and that was on board that vessel, and it collected a bunch of sensor data. At some point, it ascended beyond where 5G signals could reach, and we lost connectivity. But again, it's Temporal, and it can survive outages and things like that. So once it sort of came back into the atmosphere, then it was able to reconnect, and everything just continued. Ziggy made it safely back to Earth. And so I mention all of this because we have sort of a festival right now, you could say, Camp Temporal. This summer, we're doing a bunch of webinars and meetups. We have online, if you go to LinkedIn, there'll be Temporal trivia where we give away prizes, and we have scavenger hunt. So if you want to find out more, you can go t.mp/spacecamp. And then we also have some swag to give away. And if I didn't explain this backstory with Ziggy, you would say, why is the strange man passing out astronaut ice cream? Now you know why. So I have some for everybody. And I will come back around and I'll give you stickers. And by the way, if you're watching this online, you can scan that QR code and we'll send you some. We didn't leave you out. We will send you some. There you are. Yes. And that's it. So while I'm passing these out, any questions?
I have one. Do you support languages like Kotlin and so forth with your APIs, so you're not limited to just Java?
Yeah, well, the answer is, I have two answers for that. Plenty of people use, you get one too. You can use the Java SDK. You can do that with Kotlin, and you could do it from Groovy and any JVM. That feels weird. Oh, there you go. So there's not a Kotlin specific SDK. There have been some people who've asked about one. There's demand for it, I would say, but there is not currently one, but people that are doing Kotlin just use the Java SDK. Incidentally, I mean, it's all open source and it is possible to create your own SDKs. And there's a handful of people who've done it. And relevant to the needs of the Java community, I would say one of them is Closure. So there's a Closure SDK that someone created. So the community member created their Closure SDK. That's been around for a couple of years. And then there's a company called Mercury, a fintech company, maybe you've heard of them. They do a lot of stuff in Haskell. So they created their own Haskell SDK. And they gave a presentation about it at our Replay conference earlier this year. It's very interesting to meet the people behind that. And yeah, so it's possible to create your own SDK. There's not currently one for Kotlin, but somebody could definitely create one.
Okay, does anyone have any other questions for Tom?
The web UI, is that also open source?
Yes. Yep.
So the web UI is also open source, yes, to repeat the question.
Oh, sorry about that. Yes, the web UI is also open source. The Temporals, the cloud service that I was talking about, if you go to Temporal's website, across the top, there's a thing that says Temporal Cloud, and that's where you can get in touch. Or if you want to know more about it, the person, Steve, sitting at the end of the row, he is the other Temporal employee in St. Louis. I finally have a compatriot after 3 years, and what a great one he is, and he's a solutions architect. And so he could tell you more about it if you're interested, but if you go to our website, you can find it across the top.
Yeah, is it on a cloud? So if I'm in St. Louis or if I'm in Australia, you have a server close that's going to be basically geographically close.
Did I give you a stick? There you go.
Low latency, I guess, for that. Yeah, okay.
Last time I checked, there were 13 AWS regions and a handful of GCP. We added support for GCP last year, so there are fewer of those at present. It could be more than that now. It's been a few months since I've looked at the list. Yes.
I had a couple of fairly deep technical questions,
All right.
but I won't take Steve's answer because I've worked with him before. Um, The annotations, are those compile time annotations or runtime annotations that work maybe through AOP injection or?
They're compile time annotations, I think. I'm not 100% positive about that. Yeah, I think they are.
Okay, so at compile time, it's like analyzing the source code and figuring out what to inject based on the annotations. Kind of like Lombok does, it's compile time. I was asking if it was compile time, bytecode injection, or AOP, which would be runtime. Okay. And so then it wouldn't have any issues whatsoever with native code compilation for something like Graal. Okay, because I was also curious about how it determines the context of the JVM that needs to be checkpointed to the server. Okay, fair enough. Yeah, so I mean, given what you've written and what the workflow does, it's going to have access to so many variables that are part of its work state. Obviously, it doesn't care about the entire heap or stack, but a very, very small part of it based specifically on what the workflow is doing. So I was just curious from a technical perspective. I don't have to have that answer tonight.
And despite being a Java programmer of many years, I wrote Java every day as a software engineer for 12 or 13 years. I have spent a lot of time since I joined Temporal using Go, a language I'd never used before, but I had to learn it because that's what the server software is written in. And so like even though I'm a Java developer, I have a bit less experience with the Java SDK.
You like Kotlin?
I gotta admit, I have barely used it. I like it. I mean, I've seen it and I find it like refreshingly concise and not horrifying like Scala. I thought that was kind of a beast, but yeah, I like what I've seen, but I've never had to write any serious code in it. I've read it, but I've never really written it. Do you like Kotlin? I feel like, at least for me personally, I wrote Java code every day for a long time and tons of it. And then, but that was at a time where there was great stagnation in the Java world, you know, like the winding down of Sun and the beginnings of Oracle taking over. And they're just, you know, the whole world was using Java 6 and Java 5 or whatever. And so like most of my time, even though Java, like Lambdas had been out for a long time, you couldn't use them because, you know, companies that use Java are often like, no, we're using the old stuff. And so I was aware of Lambdas, but I couldn't use them. And I certainly didn't have all of the benefits that appeared in Java 8 and later versions. And so I had stepped out of the Java world for a long time, not intentionally, it just was, I was doing stuff in other languages. And so like, as I've sort of come back into it, I'm like, wow, they're on a rocket ship now. Java 21 is like, fast forward right into the future. And there's a lot of things that never bothered me. A lot of people in Java would complain about it. It's so verbose and you have public static void main. I'm like, whatever. IDE generates it. It never really bothered me. And then I started doing a bunch of Go, and then I went back to Java and I'm like, okay, I get it now. And then, but they're changing the language and getting rid of a bunch of that stuff and like getting rid of a lot of the ceremony and making it more concise. And so I feel like there's a lot of interesting stuff happening in Java world these days. Anyway, sorry, your question.
I have a question on, if you did crash or stop the application and change the code, maybe a different version or updated the code, would it still be able to continue on where it left off?
That's a great question. Let me repeat that. What happens, I'm going to ask you, I'm going to repeat what you said, and then I'm going to throw a variation in for this. That might be a more common thing that people experience. What happens if your application changes? I mean, your application crashes, and then you restart the work, or you start the worker back up again, you have a new version of code. And a variation of this might be, what happens if you've got a workflow execution? Because you told me, Tom, in the very beginning, you can have workflows that run for weeks or months or years. You can have a sleep statement that has a duration of 30 days or 90 days or 2 years or whatever. So you have the ability finally to run things for long periods of time. The business needs change during that time. So how do you say, like, well, it used to be that we sent a fax at this point, now we send a text or an email. How do you make these sort of changes to something that's been running for a long time without breaking stuff? And the answer is, if you change your code, like while the workflow executions are in progress, there is a chance that you can break things and you can wind up with the dreaded non-deterministic error. Not because you did something inherently non-deterministic in your code, like generate random numbers and make decisions based on that, but because you ran some stuff and now the event history says we called this activity, that activity, the other activity, and now the code is incongruent with that because you've changed the order of activities or you removed an activity from the code. And so you'll wind up with a non-deterministic error because that's temporal saying, I can't use the previous history to be able to reconstruct the state of the workflow execution using the updated code. So like, throw my hands in the air, I don't know what to do. This is something that happens to users all the time because they will make changes without sort of thinking them through, or they maybe don't understand how the system works. The way to avoid it is to use versioning. So there's multiple methods for versioning in Temporal. The one that is currently the most common, there's another sort of better one coming down. It's like in beta, you could say right now, public preview. But the one that most people are using in production right now is called patch versioning. And effectively, what it is that you do is if you're going to change something, like you had activity A and then activity B, and then you decide, oh, I want to run those in the other order. I need activity B to come first and then activity A. You can do that, and you'll write some code inside your workflow that says, if this is an old workflow execution, run activity A and then B. If it's a new workflow execution, run activity B and then A. And so you can preserve the execution path for old workflows while changing it for new workflows, and that is how you around that error. If you screwed it up and you encounter this non-determinism error in production, you can also do what's called a workflow reset, which allows you to sort of undo, you can sort of back up in the event history some number of steps to before that error occurred, and it'll start re-executing the code, and that will get around the error. Yes?
Tag along with that then. So I guess, is it possible to have two different versions of, like, say, a similar workflow, like, deployed at the same time? So like, say if you got version A and then you do version B, is it possible just to have that, that original, I guess, task that was put in there when version A was out there actually get to like a node that has, or a worker that has like that original workflow? Or do you have to compensate in like code saying like kind of like you were mentioning?
The question was effectively, could you ever run into a situation where you have two different versions of the workflow that are out there and the wrong worker picks one up and it does the wrong thing? And I would say the answer is no if you do your stuff right. And you would have to really, I'm really having trouble envisioning a scenario where that could happen. You'd like have to go out of your way to do it. There's the patch versioning that I talked about. All the workers are able to run either like version 1 or version 2 of the workflow, and the conditional logic as to which they run is inside of the code. So they don't really know the difference. They just run it, and they're either running the old thing or the new thing, but they don't have to think about it because it's just an if-else statement. For the new thing, which is called worker versioning, what happens is that you have some workers that are capable of running the old workflow and some workers that are capable of running the new workflow, and Temporal automatically routes things to the correct one. So unless there was a bug in the Temporal server software, or unless you mistagged something yourself, that wouldn't happen. I wouldn't say never. I mean, there could be a bug, but we're very careful. Like, reliability is what we do. So I think that'd be unlikely. Yes.
They scanned the QR code and I tried it, and it's asking for access code to view the
Oh, man.
view camp temporal portal.
Yes. Sorry, my mistake. The apparently the thing is asking for an access code. We're gonna get this solved. Bear with me for just a second. There we go. Urgent. Okay, so here is the access code. If you scan the QR code and it's asking for an access code so you can order stuff, it is Ziggy in space. I apologize for that. I was using Keynote and the person sent them to me in Google Slides and I forgot to copy that part. So Ziggy in space with a capital Z is in zebra, capital I is in India, capital S is in space. I guess Z is Zulu. Zulu, India, Sierra. Okay, my apologies.
Okay, well, if there's no more questions, then this is normally where we have a big round of applause here for our speaker. Thank you for coming, and thank you, I forgot to thank you for sponsoring the pizza tonight.
It was our pleasure. Enjoy. There's still some left over, so if you were being bashful at first and you want some more pizza, what programmer doesn't love pizza? So help yourself.
And thanks for the prizes as well.
Yeah.
Okay, so if you are online, stay online, but at this point, I think we're going to turn off the recording and head into the raffle. So give me the signal, Ted.